Hi guys, welcome back to another Limitless Math video tutorial. In this lesson, we are going to calculate and solve equations with special cases, and we'll determine how many solutions they have. So let's get started. Welcome to the video. In case you missed the subliminal messages in the background, we are on the way to 1,000 subs, so please like, share, subscribe if you need math tutorials. Let's get started with example number 1. In the red box, we have 8 times 3x plus 10 equals 28x minus 14 minus 4x. And like we've said numerous times before, what you would like to do first is completely simplify both sides of the equation. Let's start with the left side. We do see a set of parentheses. We'll distribute to simplify. 8 times 3x is 24x, and 8 times 10 is 80. And just simply bringing down the other side. How do we know if a side is completely simplified? We check to see if we have just one variable and just one number without a variable. So 24x and 80, we cannot combine because they do not play for the same team. 24 plays for team X. It has an X on the back of its jersey. You can see it clearly behind it, okay? 80 plays on the team no letter, no variable. That's why there's no letter behind it, okay? They are on 2 different teams. We cannot combine it, okay? So we'll just leave it there for now. Going to the right side, we want to simplify it as much as possible too. 28x minus 4x, those are on the same team, team X. We can put those together. 28 minus 4 is 24x. And the negative 14 we bring down. Remember, there's no combination with those two not on the same team. So once we have both sides completely simplified, here is the point where we start to move things across the equal sign. I like to start with my variables first. 24x and 24x need to get together. We need to choose a side for them to go to. So I'm going to subtract this 24x here. And remember, you have to do it on both sides. So 24x minus 24x cancels and gives me 0, but I'm highly skilled, so I'm not going to write it. That leaves me with 80 over here. And 24x minus 24x on this side also cancels, leaves me with 0, which I cannot write, and then negative 14. Here is what we mean by special case. A special case equation is one where the variable eliminates completely. While you're solving it, you follow all the rules, cancel, take every step carefully, and the variable goes away. That is a special case. Sometimes you end up with something false, like this scenario. 80 does not equal negative 14. Since this is false, this special case is a no solution. So there is no solution to this equation. And you can clearly see, I'm a math teacher, not a spelling teacher. No solution. Sometimes the variable cancels and we end up with something that is equal, like if this was 80 equals 80, or negative 14 equals negative 14. Then we would say this is a special case with infinitely many solutions because any value that we plug in for the variable will work. So we'll probably see one like that pop up in a little bit. But no solution means no matter what we choose for x, nothing, absolutely nothing will make this equation be true, okay? Let's move on to example 2 in the green box. 12z minus 6 plus 15z equals 27z minus 5. Once again, combine or simplify each side completely. 12z, 15z is 27z. Minus 6 equals 27z minus 5. Once again, both sides are now simplified. I can tell because we have team Z and we have team no variable. Everything's simplified. Let's subtract 27z on both sides. Okay, that cancels, leaves us with negative 6. Over here, cancels as well. This time leaves us with negative 5. So our variables eliminated. This is a special case. Negative 6 does not equal negative 5, so this is no solution. And I'm going to play it safe and just write NS. Example 3. 74y minus 8 minus 78y equals negative 4y minus 8. Let's simplify both sides. On the left, 74y pairs up with negative 78y. They're on the same team. Using those integer rules, that should be negative 4y. Bring down negative 8 equals negative 4y minus 8. Okay, let's make sure that we get these variables together now that we have both sides completely simplified. So add 4y, add 4y. Y's cancel, negative 8. Over here, cancels again, negative 8. So another situation where the variable disappeared, but this time we get something true. Negative 8 does equal negative 8. So this time we have infinitely many solutions. Infinitely many. Yay, spelled that right that time. Last example for this video. In the blue box, we have 7 times y plus 3 equals 5y plus 8. Simplifying both sides, let's start with the left and distributing. 7 times y is 7y. 7 times 3 is 21 equals 5y plus 8. Now, before we even go further into this, it should be obvious, apparent to you that this is not going to be a special case. Okay, you can pick special cases out kind of early on once you notice you have the same coefficient and same variable on each side. So in this last example, we have 7y, 5y. They're not the same, so we're going to be able to solve this equation like we have done in the past. The yellow example, the coefficient and the variable matched, negative 4y, special case. In the green example, they matched 27z, 27z, special case. And in the red example, they matched 24x, 24x, special case, okay? So when the coefficient and the variable are exactly the same, after you have simplified both sides, it is going to be a special case. It is either going to have no solution, 0 solutions, right? No and 0, same thing. Or it's going to have infinitely many solutions. Those are your options for special cases. When it is not a special case and the coefficient and variable does not match, then you're going to end up with exactly one solution, which is what we have seen prior to this video. So we subtract 5y on both sides. 2y plus 21 equals 8. Subtract 21 on both sides. I'm running out of room. So that leaves you with negative 13. divide both sides by 2, and this is not a whole number. We can just leave it as y equals negative 13 over 2. But it's exactly one solution, okay? Thank you guys so much for watching. Remember to click the like button, subscribe, and to share this video. We are trying to get to 1,000, and I'll see you in the next one.